Okay, well, let's get started. So today we're going to continue the idea of what we've been doing with projecting points. And we're going to take this and apply it to lines now. Now, so far, in a couple situations, we've projected more than one point on the same exercise. If you were to connect those 2 points, you'd have a line. Pretty straightforward. So in terms of projecting the points and what we're doing functionally, we're going to be doing the same things that we've been doing, but we're going to add a couple of new considerations to it. Most chiefly classifying a line. What type of line is it? So, just a quick definition of the line itself. It's just a locus going through space connecting 2 points typically. Technically, mathematically, a line continues on forever in each direction, but we're just going to be looking at a segment of a line, if you will. And of course, it's the quickest distance between those 2 points. When it comes to classifying them, basically we classify a line as what is it parallel to? What view is it parallel to? And we also classify it as where do you see the true shape? We'll talk more about the true shape in just a moment. But basically, again, we're just looking at what is the line parallel to? And the choices are, of course, we have our 3 principal planes that we've been dealing with, right? Horizontal, frontal, profile. So it could be parallel to one of those 3 principal planes. It could be a special one in the case that it's a vertical line. And it could also be an oblique line, meaning that it's not parallel to any of the principal planes. So taking a look at a few examples here. Here we've got line AB. It's in the front plane, but it's parallel to the horizontal plane. Therefore, it's a horizontal line. And logically, if you look at it, if you see it in the front view and it shows up as a horizontal line, then obviously it's a horizontal line. What we don't know is A and B the same distance away from my eyes? Does it go further away from me as it goes from A to B? And that honestly doesn't matter right now when we're classifying, because even if it does get further away from my eyes, it's still horizontal. It still does not travel up or down at all in the elevation view of the front. So it's parallel to the horizontal plane, therefore it's a horizontal line. So here I have a line that's drawn in the horizontal plane, and it is parallel to the front plane. So therefore it is a frontal line. In this case, I have a front view and a horizontal view of line FG, and in both cases, that line is parallel to the profile plane. So this one's parallel to the profile, this one's also parallel to the profile. So it's a profile line. In this situation, this line is parallel to the profile plane. If I were to draw out what the profile view would look like, of course I would take my 2 rays from F and G, and then I would get my offset values up here, and they're both the same, right? F and G have the same offset value, so I'd end up with just a vertical line out here as well. So it's parallel to the profile, it's parallel to the frontal, but it's a special situation, it's a vertical line. So I would not classify this one as both profile and frontal. The correct classification is it's a vertical line. So the way I usually kind of abbreviate that is if it shows up as a point view in the horizontal plane, it's a vertical line. Then if I have a line that's not parallel to any of the principal planes, it's simply an oblique line. So where we're going with all this is we want to be able to find the true length of a line. So how long is any given line that we're dealing with? And let's talk about line AB here that I've got. Now, could I measure line AB? I would say that yes, I could at this point. Could I measure line AB right now? It's foreshortened, right? A is closer to me than B, so I can't measure it. So you can only measure a line if we are actually seeing the true length of the line. And so right now I'm seeing the true length of the line, right? So the relationship of my eyes to this line is perpendicular. I'm looking straight at the line. So therefore, I can only see the true length of a line if I'm looking straight at it. My view is perpendicular to that line. So remember when we're talking about perpendicular 90 degrees, that's what a hinge is, right? Each one of these hinges represents a bend of 90 degrees, a perpendicular look at a plane. So we'll need to construct a view that is a true length. So let's say I have a line. Let me just put it this way. Let's say I have a line that's at an angle, and I want to find the true shape of it. So what I'm going to need to do is I'm going to need to look perpendicular to it, or this way. It could be various different ways. And so the way that I look perpendicular to it is I create a hinge that's parallel to it, and that means I'm looking perpendicular to it from this view. So remember, a hinge is just a 90-degree change. So if I make a hinge parallel to this line, this view means I'm looking perpendicular to it. I'm looking straight at this line. I can then see the true length. So let's switch back and see that in the slides here. Oops. So the big difference today with what we've been doing is you've been given the hinges up until this point. Now you are going to have to construct your own hinges. This goes back. Oh. Resolution issues. Hang on, let me try one more time. Oh, it wants to start out right and then it screws up. Oh, I'll run with it. So the true length of the line is found only in a plane of projection parallel to the line. So again, we're going to create a hinge parallel to it and then project across it. So if I take a look at these two lines here, FG, again, it's an oblique line, so I can't find the true length. So I'm going to need to create a hinge that is parallel to the line. Now, technically, I could do that up here off of the horizontal, or I could do it off of the frontal. Reminder of some terminology: when I hinge off of the horizontal, it's an auxiliary elevation. When I hinge off the front or the profile, it's an auxiliary incline. This will be more important next class period when we start talking about slopes of lines and which views we can actually view the slopes in. So for now, hinging off of FG here, then it's the same thing we've been doing. I'm going to take point F, I'm going to draw a line perpendicular or a ray perpendicular across this hinge, go back 2 views, get the F offset value, that'll give me point F. Same thing for G, ray perpendicular, go back 2 views, offset, that will give me the point that I need for G. So again, that's just to show that the spacing is the same there. This is now a true length line. So I'm going to label it with a TL. I guess I don't have that here, but I'm going to label it with a TL on the assignments to indicate that that line is true length. Occasionally you'll be asked to measure it as well.
TL next
to the line itself. Yeah, just to show me that this is a true length line. And so again, I know it's a true length because this is parallel to this hinge. The resulting view is a true length. So let's switch back to the line here. So if this is a true length line, and I want to see the point view of this line, I just want to see it lined up towards a point, I'm going to rotate it up 90 degrees until I have a point view. And that will show me just the end point view of that line. Now, depending on which way I want to approach it, I might show the point view of one line or the other. Or one point or the other, I should say. So again, how do I rotate 90 degrees? I have hinges, right? So if I have a hinge perpendicular to this line, so no matter which way it is, if I have a hinge perpendicular to this line, this view over here is going to give me the point view, because the rays from A and B are going to line up, and the view it came from, the space for A and B should be the same distance away from the hinge. So let's look at that over here. So once the true length has been constructed, then we create a hinge perpendicular to that true length line. Then we project across. So again, F and G are going to line up in the same row. And as I go back 2 views, F and G have the same offset distance. That's what's going to give me a point. Now the important thing about labeling here, first of all, you're going to be asked to label it as the point view, so just a PV. And then you're also going to be asked to label it properly. So you show, for example, here I have A to B. If I bring it up this way, A is closest to my eye, so it's going to be A2, B2. Or if I go the other way, if B is closest to my eyes, then it's B2, A2. So you always put which one's first, closest to your eyes. So in this case, I would be expecting that the point would be G2, F2, since G is closest to my view here. And again, the 25 is just to show you where the offset value came from. Okay, so bearing and slope we're going to get into next class period. I'm going to switch over to AutoCAD real quick. Okay, so let's work on a couple of these together. So if you'll go to New, and then your Templates folder. And then as usual, I got some extra ones for us to do together in the Additional Files folder. Then you'll see one in here called Line Practice. So as I take a look at the first one here, the first thing I want to think about is, do I have any true length lines? Is there any parallel relationships here? No. So there's no true length lines. If I talk about classifications, it's not parallel to the front, so it's not a frontal. It's not parallel to the horizontal, so it's not a horizontal. It's not parallel to the profile, so it's not a profile. It doesn't show up as a point in the top view, so it's not vertical. The only thing left is oblique. So that's kind of my process for figuring out what kind of line it is. Figuring out what is it parallel to. If it's not parallel to any of those, then all that's left is oblique. So the next thing I want to do then is create a hinge that will be parallel to one of these two lines. Now if I look at my instructions, I'm told to find one in the auxiliary elevation plane. So should I hinge off of the horizontal or the frontal? For an elevation. Horizontal. And I kind of made more room for you to do that. So remember, it's an elevation when you hinge off of the horizontal. So to create this hinge line, I'm first going to make sure that I have the hinge lines layer current. And we're going to use a parallel snap. Quite honestly, if you turn parallel on in your running mode, I think it gets in the way and doesn't always work the way you want anyways. So I'm going to strongly encourage you to do this as an override. And the way this works is I'm going to start the line command, and I'm going to pick the first point of my hinge. Now, where this line is really doesn't matter. You are going to create it. The only thing that it affects is later on 2 views down when I'm creating my point view. How far away that point view is from that hinge is driven by where I draw this hinge. So if I draw it way out here, I might run out of space. So I always try to draw relatively close to the line. So maybe I'll pick a first point here. And then I want this line to be parallel to that line. Now right now my polar tracking is on. It's tracking at a 45. That's not correct. So I don't want to just blindly draw up on screen. I want to be parallel. So to make it parallel, hold the Shift key with your left hand and right click your mouse. Then you can let go of the Shift once the menu pops up. And you want to choose the parallel object snap. And with parallel, you do not click on the item you want to be parallel to. You just hold your mouse over it. So if you hold your mouse over this line and move it away, you'll see a little tracking point show up. And then you can bring your mouse up to where it's parallel. You'll see it lock on the tracking angle. And then you can click to place your line. Now obviously I want this line to be longer than the line I'm coming from because I'm going to be projecting across it. And then I'll just escape to deselect that. Let me do that one more time in case anybody had any issues. I'll start the line command, pick a point in space, Shift right click, click on parallel. Don't click on the line, just hold your mouse over it. A couple of warnings. If you move your mouse back over the point, it gets rid of it. If you zoom or pan, it gets rid of it also, which is no big deal. I can just hold my mouse back over it again. Then watch for the tracking. As long as it's locked in, then you can click to place your line. So, making sure that I'm doing things correctly as I go, you got to make sure you label your hinges also, not just your points. So that'll help me keep things straight. So I'm now going from the horizontal plane into auxiliary 1. So I could use the text tool. I'd prefer to just copy the H that's already there. So I'm going to copy, select the H and hit enter. Pick a point somewhere nearby that H, and then I'll click on this side of the hinge and that side of the hinge. Then I'm going to double click on this H and edit it into a 1. So I'm going from horizontal plane to auxiliary 1. Then we're ready to do what we've been doing, which is use rays to project these points across. You can do them one at a time, or you can do both at the same time. Be very careful though that you don't mix them up. So I'm going to go ahead and change my layer into the projection lines layer. You don't have to do that step, but it helps me keep things clear. Then I'm going to draw a ray from point A perpendicular to the hinge. And I'm going to go ahead and do them both at the same time. I'm going to live dangerously here and draw a ray from B perpendicular as well. Now for my offsets, I'm going to start the offset command, and I'm going to choose my layer option and then current so that it comes into the current layer of projection lines. And so coming back 2 views, my first space is going to be this AF to the hinge here, and that'll be my A. Then my second offset value will be BF to the hinge. And there's my 2 intersections. So the biggest problem at this point is doing this. Is that the correct line? A should be the closer one, right? So if you do both at the same time, pay attention to which one's which, and if it's easier, just do one point at a time. Make sure you get the right thing. Now, I don't care if you actually use the point command and put a point there. Now that we've got a line, it's pretty obvious that the end point of the line is the point. So I'm going to delete those construction lines, and again, I like to copy the labels and edit them. Just have to remember to actually edit them if you copy them. That's B, that's 1, and 1. Then I need to put my true length label on here. So this line is true length. Since we created a view parallel to the line. Now if it's an exercise that asks you for the dimension, which I'll sometimes do, then you'll just use the dimension tool. This one's brand new in AutoCAD 2016, and used to be we'd have to choose the linear or the aligned, and you can still do that separately up here, but this new dimension tool is pretty smart. If you hover over a line and select it, it's pretty smart on figuring out what you want to do, and it'll switch between horizontal, vertical, and aligned. So this would be the appropriate dimension. Quite honestly, I stopped having you guys dimension most of these because I was finding these really small fractional errors, and it was opening up a big can of worms. So it's to your benefit when I don't have you measure it. So now that I have the true length, my next step is to create a view that will allow me to see the point view. And again, that view is going to be perpendicular to the true length line. So to construct this, it could either go down here or it could go up here. Obviously, I probably have a little more room down here, but it's getting kind of crowded with the other stuff. Sometimes on these drawings, if you want to erase the text that's there so that you have room, I'm okay with that too, but I should be able to bring it down and project it down this way. So the strategy for creating this hinge, first of all, make sure that I'm in the hinge lines layer. And what I will typically do is I'll just kind of start out here in space and draw perpendicular to the line, and then I'll move the hinge line down. So I'll start a line, maybe out here in space, perpendicular to the true length line. Then I'll escape out of that. And then if you pick on the hinge, you can grab its middle grip and just drag it down here in space somewhere. The most important thing is that when I draw a ray, I'm actually crossing over this hinge. Sure, let me do that again. So just draw a line, just kind of out in space next to the line, and then go perpendicular to the line. And then just escape out of the command, and then select that hinge line, and you can grab its middle grip. Don't grab the end grips because that'll stretch it, but grab the middle grip and then just bring it down where you need it. So let me show you guys something that will goof up your drawings pretty quickly, and that is grabbing this grip and stretching it. So one of the reasons why I kind of use this strategy where I create it in here and then I move it is if you start out here in space to create your hinge and then you shift right click and go perpendicular and click on the true length line, it creates a line that's perpendicular to it, but your ray doesn't really cross over it, so I want to maybe move it or stretch it. If you grab this grip and just pull it, you're changing the angle. So even if it looks like it's going to be okay, it's not. You're going to be messing it up. So if you do want to stretch a line out, if you click on it and just hover over the grip, don't click on it, you'll have a couple of choices of stretch and lengthen. Choose lengthen, and that will let you stretch out the line without changing the angle. But I see a lot of drawings where maybe that first hinge was off a slight bit, and then 3 views later, nothing lines up, and you pretty much have to start all over. So it's really key that you don't just grab that grip and stretch it out. So now labeling my hinge to make sure that I know where I'm at and where I'm going, I'm going to copy this one from this side to the other side. And then I'll edit this side and make it 2. Auxiliary view 2. Again, I'm going to go ahead and change my layer to projection lines, and then I'm going to create a ray to project across. Now, one of the things I like to do is instead of starting at point A1, I like to start at the back point, B1, and then go perpendicular to the hinge, for the simple reason that if I did that properly, it should run right through A1 anyways. And so I can see pretty quickly if my hinge wasn't perfectly perpendicular, it wouldn't line up. So then once more, I'm going to go 2 views back for my offset, 1 and 2. A and B are the same distance away from that hinge. That is why I'm going to get a point view. So I'll offset, pick any point on that line perpendicular to the hinge. That is going to be my point view. Now again, every one of ours is going to be different, because we all drew this hinge line ourselves. We all would have done it a different distance away. So therefore this view over here, some of yours might be closer to the hinge, some of yours might be further from the hinge, just depending on where you put this one. So they're all right. All that does is it just makes it more difficult for me to grade these assignments, but for you guys it's great. So then I'll go ahead and delete that and put this in the points layer. So then to properly label this, you're going to need to put 2 things on there. First of all, you will need a label that says PV for point view. Then you will need to label the points. And again, instead of typing, I like to just copy one of these existing labels. These ones are now going to be 2. So should I start with A or B on this one? Should it be A2, B2, or B2, A2? So as I look over in this view, A is the closest when I'm looking, so it needs to start with A. So therefore the proper labeling would be A2, B2. So I tell you what, on the second one, just in the interest of time, I'll just buzz through this one. You can watch me and take it all in. I'm just going to do the same steps, but I'll do it a little quicker so that you guys can get started on the exercises. So find the true length in the auxiliary inclined plane. And then I also need to find the point view. So auxiliary incline means I'm hinging off of the front or the horizontal. Classification, is this a frontal, horizontal, profile, vertical, or oblique line? Oblique because it's not parallel to any of the 6 principal planes. We'll talk more about classification in just a minute. So again, I'm going to create my hinge line. I'm going to use a lot of keyboard shortcuts here since I'm going to do this one quickly. Parallel to this line, I'm going to label my hinge, going from front to 1. I'm going to use my raise, perpendicular. As you can see, I didn't change my layer that time. Offset 2 views back. D is the close one. Whoops, went the wrong way, but I'll just keep going. C is the further one. So I always say that out loud to myself so that I know which direction I need to draw this line. So D was the close one, therefore this is my true length line here. And again, I'll label, just using the CO keyboard shortcut to copy. That'll be a 1, this will be a 1, and then I need a TL label here. Then I need a point view, so I want to go perpendicular to this line. So again, I'm going to switch back to hinged lines. I can go either direction. I'm going to go down here towards the bottom. So I'll draw a hinge line perpendicular, move it over here, and again, do some labeling. I'm using my CO shortcut again. That's a 2. Now I'm going to draw a ray from D perpendicular. Oops, see that? I went to the midpoint. That was bad. So I'll try that again. Ray here, perpendicular. Runs through C, so I know that's right. So then I'll go ahead and go back 2 views for my offsets. C perpendicular, PO for point. There's my point. Now I didn't really change my layers at all, but now I can put my label in. Should C come first or D come first? C. Yep, because that's what's closest to my eyes as I look that way. And then the last thing then is my label that just says PV. Well, I thought I hit that button. Let's try that again. There we go. So let's talk about today's exercises, including the drawing that you are going to be classifying lines on. So we're going to do lines 1 through 4 today. And the first one, lines 1, you really just can print this and write on it, but please don't print while I'm talking here. You can print after I'm done. I'm going to rotate my screen here so you can see this, and we'll talk about this one together. So as I look at these lines across the top, again, you classify these lines as what is it parallel to, or alternatively, really the way I like to think about it, where do you see the true length? So in number 1, where do we see the true length line? So this is parallel to the horizontal plane, so therefore this is true length. So that means it's a horizontal line. And again, I can tell that by looking at the front view. That makes sense? So this line's parallel to the horizontal plane, therefore that's true length. Since I see the true length in the horizontal plane, it's a horizontal line. So number 2, where do I see the true length line? In the front. This is the true length. So So therefore it's a frontal line. This is parallel to the front. This is true length. What about number 3? What's this parallel to? The horizontal? What's this parallel to? The frontal? So we could classify it as both. What would my side view look like? My profile view? Point, yeah. So if this is true length and I create a hinge perpendicular to that, it's just going to be a point over here. Good. Let's skip number 4 and go over here to number 6. What would this be parallel to? Profile? What would my profile view look like? Same thing, so it would be parallel to the front. But instead of calling it a frontal or a profile, since it's a point in the top view, what kind of line is it? Vertical. So let's go back to number 4 here. What is this parallel to? Profile? Is it a vertical line? No? So it doesn't show up as a point view up here. So this one tricks a lot of people. They see this line here in the front and they say, oh, it's a vertical line. It's only a vertical line if it's a point up here. So I would need to construct my profile view to see the true length. So it's parallel to the profile like you guys said, so it's a profile. And you got an oblique one and another one here that you guys can work through. So that one, again, you can just print off and write all the answers in. Again, please don't print while I'm running through these though. And then let's look at lines 2, 3, and 4. Lines 2, pretty similar to the one that we just went through together. So number 1 here, find the true length in the auxiliary elevation. So that means you need to hinge off of the horizontal. Try to make it obvious by the placement of these as well. So you are to find the point view as well as the instructions say. So number 2, do it in the auxiliary incline. So that means you're going to hinge off of the front and go this way. And then number 3, auxiliary elevation. So you're going to come off the horizontal again. By the way, on these plates that are sideways, you can still just double click on the name and enter your name in and click away from it. It still works even though it's sideways. So that's lines 2, lines 3. There you go. More of the same. So let me ask you a question about this one. Do I already have a true length? Yeah? So you don't have to construct that view, you just have to label the true length and then construct your point view off of it. Do I already have a true length here? Yeah? This is true length, this is parallel to the front, this is true length, so you just have to create the point view, but you also have to label your true length. True lengths here? More than one? This is parallel to that hinge, so that's true length. That's parallel to that one, so that's true length. So then you just need to find the point view. So most easily would be to do the profile view. Now at the bottom, you're asked to classify each line. So just use your text tool and tell me where you see the true length. Do you see it in the frontal, profile, horizontal? Is it a vertical? If none of those, then it's an oblique. So as you can see, EF can be classified 2 different ways. And then the last one, these were actually the same drawing, but I split them apart because it was way too busy. So lines 4 is more the same. So construct a true length and a point view, true length and a point view. Let me ask you a question about this one. Do we have a true length? Yeah? Do we have a point view? Yeah. So this one you can kind of work backwards. If you've got a point view, then this has to be true length. It's a vertical line. You could construct this side view, but like you guys told me a while ago, it's going to look just like the front view. So that one you mostly just need to label and then also classify each line. So lines 1 through 4, again, the first one you can just print out and write on if you want. Or you can use the text tool and do it in AutoCAD if you prefer. I don't care either way. And then 2, 3, and 4. So let me know if you guys run into any questions.